In this video, we will solve and graph one-dimensional inequalities. So first, let's graph some inequalities. We're going to graph these inequalities on the number line. We have x that's less than 3. So the value of x has to be any number that's less than 3. So the way we do that is we shade on the number line all the numbers that are less than 3. Now, we need to indicate whether or not 3 is included in the solution. Because it only says less than and not less than or equal to, we are not including 3 in the solution. The way we indicate that is with an open circle. The open circle indicates that 3 is not included in our solution. All right, for number 3, we have x is greater than or equal to 4. So the number that makes this inequality true is going to be any number that is larger or exactly 4. So we're going to shade all the numbers to the right of 4 because those are all the numbers that are larger than 4. And because 4 is included in our solution, 4 is greater than or equal to 4. We're going to use a closed circle or a shaded in circle to indicate that 4 is in our solution set. Okay, so to go over this again, we're going to use an open circle when we have less than or greater than, because that value is not going to be included in the solution. So you're going to be using an open circle. We're going to use a closed circle when we have less than or equal to or greater than or equal to, and we'll use the closed circle. Numbers 2 and 4 I want you to do on your own. Here we're given the graph and we want to write the inequality. So for number 5, we have all the numbers shaded that are to the left of 13. Those are all the numbers that are less than 13. We also see that we have an open circle at 13. This means that all of our x values, or whatever number is a solution for this inequality, has to be strictly less than 13. We don't have or equal to because it is an open circle. For number 6, we have a closed circle at 7, and the shading is to the right. So all the numbers that are a solution for this inequality are larger than 7, and 7 is closed in, which means it's included. So x is greater than or equal to 7 is the inequality for this graph. 7 and 8 I want you to do on your own. Okay, let's take a look at multiplying or dividing by a negative value. So we're going to consider the following statement. -2 is less than 5. We know that this is a true statement. -2 is definitely smaller than 5. But what happens if we multiply both sides of this by -1? So what would that give us? Well, that would give us +2 is less than -5. Well, is 2 smaller than -5? No, that's not true. So what we need to do instead, when we multiply by that -1, is we have to ensure that our inequality is still true. So the way we do that, we know that 2 is larger than -5. So notice what we had to do in order to make sure that our inequality still held true. We had to flip the inequality when multiplying by a negative. So what about dividing by a negative? That would have given us the same result. -2 divided by -1 is a +2. +5 divided by a -1 is a -5. So we still would have had to flip the inequality. So we have to flip the inequality sign when we multiply or divide by a negative. All right, so let's look at some examples where we have to solve and graph our solution. Okay, so we are solving these the same way we solve equations, except for when we have to multiply or divide by a negative. That's the only change from an equation to an inequality. So first we would want to subtract 2, and we're left with 3x is less than negative 6. Notice subtraction, we don't have to flip the inequality. We're not multiplying or dividing by a negative, we're just subtracting. So this inequality is still balanced and still holds true. So next we need to divide by 3. When we divide by 3, we have x is less than negative 2. Notice that we're not dividing by a negative. We're dividing a negative number by a positive number. So we don't flip the inequality here. It's only when the number we're dividing by is negative. So x is less than negative 2 is the inequality that we graph. So we'll label negative 2, negative 1, and 0, negative 3, and negative 4. We know because it's not equal to, we'll have an open circle at negative 2, and we'll shade all of the numbers that are smaller than negative 2. So we shade to the left. On this example, we need to subtract 2 first. We end up with x divided by 6 is greater than negative 3. We need to get rid of the division by 6 by multiplying by 6 on both sides. So x is greater than negative 18. So x is greater than negative 18 is what you need to graph. I'm going to leave the graph to you. We have a few examples that are on your own. This next example, 5x minus 2 is less than or equal to negative 7. You need to solve and graph. 6 minus x is less than or equal to 14. Solve and graph. Negative 5/6 x minus 1 is greater than or equal to 14. And last, we have x divided by negative 8 minus 5 is less than negative 2. So those on your own examples, please attempt those before class, and we will go over those in class tomorrow.